Welcome to qnawire.
All right. So for this problem, we have this setup: Q1, Q3, and Q2. And this is the x-axis. This is the positive direction. And so this Q3 is at the origin, and Q1 is negative 0.2 meters, and Q2 is 0.4 meters. We know that the Q1 is negative 6 times 10 to the negative 6 coulombs. Q2 is unknown, and Q3 is 3 times 10 to the negative 6 coulombs. So for part A, we want to know if the net force on Q3, F3, is 6 newtons and the point to the right. So just to say 6 newtons. We want to know the charge of Q3. So because we know that the net force acting on Q3 is so just based on the Coulomb force, we know that this is F3 equal 1 over 4 pi epsilon naught times negative Q2 Q3 divided by 0.4 squared and a plus Q1 Q3 divided by 0.2 squared. Okay, so the reason why I have this negative sign here is that because Q3 is positive, Q1 is negative, and Q2 is unknown. If Q2 is positive, then we know that the force on Q3 should be pointing to the left. So this is just to the opposite of the positive, the x direction. So in that case, only if Q2 is negative, then we will have a net force on Q3 is pointing to the right. So this is the reason why I have this negative sign here. And for this one is positive, just for the same reason. And you can just plug in the value for Q1, Q3 into this expression. And this equal to 6 newtons in this case. And actually you can find, you can solve for Q2 equal, let's say, it's negative 6 times 10 to the negative 5th coulombs. Okay. And for part B, we know that F3 is also 6 newtons, but it is pointing to the left. So in this case, this is equal to negative 6 newtons. Okay. And we have the same expression for the F3, so which is 1 over 4 pi epsilon naught times negative Q2 Q3 over let's see, 0.4 squared and plus Q1 Q2, sorry, Q1 Q3 divided by 0.2 squared. Yeah. And in this case, this is equal to negative 6 newtons. So again, just plug in the value for Q1, Q3, and you can solve for Q2 in this case equal 1.15 times 10 to the negative 5th coulombs. Okay.